So task is to get an expression for distance, and what we have is an equation of v as a function of t. Then we say, boss, this expression for distance is nothing but integral of v dt. This is what we are achieving. Okay. Is this okay, guys? Are you able to follow till here?
Yes, sir.
Okay, now imagine, supposing I have a force and distance curve F and, displacement, force into distance, force into displacement. Okay, so here, what can I get from a graph like this, Fs graph, force versus displacement graph?
So could you repeat that question?
So this I explained to you, right? If
Yes, sir.
if I want S, I will say S is equal to integral v dt. Supposing I am giving you a graph of force and displacement. Okay, or you can say force and distance. Okay, what can you get from this equation? What can you get from this graph?
The work.
Well done, very good, because you know something which connects force into distance or force into displacement is nothing but work. So if you are going to find the area under this graph, right, what you will end up with is going to be work. So you will say work is equal to integral of F ds. Why we are using this dt and ds is by, you have not given me a shape which is like straight line. So here what I have to do, I have to take chotu areas and I have to find the distance. Like this, here also I have to take chotu areas, ds at a time, and f into this ds is going to give me this work. Likewise, f into this ds is going to be this work. W1 plus W2 plus W3, like that I will add up, I will get the total work. Okay, so basically when you say dW means small work, like D1, W1, W2, W3, small work is dW is equal to F ds, integral F into ds. W will be the summation of all such chotu works. So that will be nothing but integral of FDS. Okay, so we are saying small work is equal to F into ds. Total work W will be equal to integral of F into ds. Do you understand this? Yes,
Yes, sir.
yes, no, all right, fully confusing. Something you tell me. In fact,
Okay.
Keshav, if you understood your question, where you are asked to calculate energy or you are asked to calculate some work, no? You said
Yes,
S
sir.
proportional to S to the power of minus 3 by 2, some question you had asked, right?
Yes, sir.
I think there also we have to do some integration there. We will discuss that subsequently.
Yes,
But
sir.
okay, you have to just judge. Hey, what is it you have given me? If I find area under the curve, what is that? What is the entity I'm going to get? Here I will get V into T means distance, Baba. F into S means here it is work done. So like that, meaningful relationships you do, because you can't integrate anything with anything, isn't it? It should make sense. Only then you will be able to get something useful. Is it okay? This is what we.
So actually, the problem is I've done other integration questions from the chapter,
That is fine.
but
We will take separately. Let's not get specific into your question. I'm just telling you here in that context. All
yes,
right?
sir.
Okay. Guys, did you understand what you mean by this integration? I want to hear from Hana.
Yes.
I want to hear from Chaitri, Nihar. This is like having a high level understanding is very important. Do you want me to explain any aspect of this, Nihar?
Got it, sir.
Our dear friend Aditya,
Understood, sir.
have understood, no? Is there anyone whom I have not asked? Only four of them are there. Keshav is also there. Neha, how can I forget her? Yeah, bubbly chubbly.
Understood.
Understood, no? Very good. Please don't hesitate to ask questions, okay? All right. Why this is important is here we are going to do one derivation for work done where, Baba, when your gas is expanding, okay? There we are going to use this procedure of integration. That is why I gave you some, what do you call, a brief about what this integration is. And quickly, we should also discuss certain formulae, boss. Okay, integral of x to the power of n. Okay, just like you have derivative of differentiation of x to the power of n is equal to n into x to the power of n minus 1. Integral of x to the power of n. Tell me, Kesha, what is this going to be equal to?
So it'll be x to the power n plus 1
Ah,
divided by n plus 1.
Very good. Integral of this x to the power of n dx, we say. X to the power of n dx is going to be equal to x to the power of n plus 1 by n plus 1. Can you quickly make a note of this, guys? Likewise, we say a derivative of sine x is equal to cos x. Okay, the reverse is true. That means integral of cos x dx is going to be equal to sine x. This is formula number 2 for you. Please make a note. Wherever you start from derivative, when you're from derivative, if you're able to get this, the reverse is also true. Integral of this guy will get you this guy. Okay. Then third thing, can you tell me what the integral of sine x is going to be then?
So will it be minus cos x?
Minus cos x. Why? Because I know derivative of cos x is nothing but minus sine x. That means when I do integral of minus sine x, I will get cos x. If I do integral of sine x, I will be getting minus cos x. Okay. And supposing I do, what is derivative of log x?
So 1 by x.
Very good. That means integral of 1 by x is going to be log x. Okay. So like this, of course, you can go on and whatever derivative of tan x, derivative of secant x, all that you write, do the reverse process, you will get the formula for integrals. Okay, but these are some common ones which you should know. And anyway, integration as a chapter is dealt with in mathematics in grade 12. But this much introduction is required for us to proceed in our physics part of it. Physics, and here you see in chemistry also they are using it. Can I get a confirmation that you have written down this formula, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Good. So now let's go ahead and get an expression for work. Okay. So Adit, can you please help me read this?
Let's consider a system where external pressure is constant. What will be the work done?
Okay. So what is the context here? We are saying, boss, I will take gas. Okay. And I am going to, the gas will either expand or doing work on the surrounding, or it may be compressed. That means work is being done on it. Okay. So either the system will do work or the system work will be done on the system, whatever the case may be. Okay. But the condition we are taking is, yeah, this external pressure is there. No, it is constant. That means we will not have the situation where here we have P. No? P is not varying, P is constant here. Let's say atmospheric pressure. Atmospheric is constant for a particular, what do you call, for a particular place. And under this constant pressure, supposing volume is changing, okay, supposing we take expansion, that means V1 is going to be the initial volume, V2 is going to be the final volume, okay, and V1 to V2 and P, what will this area represent for us? That means we are looking like this. There was a cylinder, there was some piston out here, there was some gas here. This gas had a volume V1 initially. Maybe some heat was applied to it, right? Because of which it expanded. And when it expanded, it had constant pressure here. P external is constant. Under this constant external pressure, it expanded and final volume has become, okay, this volume now become V2. Okay, so what we do, we are drawing the PV graph. In this PV graph, we have shown pressure is maintained constant. We're going to call this P external. Volume is increasing. My question is, what will this shaded area represent?
So work done.
Work done, we saw, no? When we did P into V, where before I started explaining all this, right? We did find out that P into V will always be equal to work done, isn't it? So yes, area under the PV graph, or rather here this is not V, this you can say is delta V, isn't it? That is change in volume. So P into delta V is going to be the work done by the system on the surrounding, because we are talking about an expansion process. Can you guys confirm that you understood this so far?
Yes,
Yes,
sir.
sir.
What are we doing? We are using the integration process and area under the graph. Area under the graph is nothing but work. So when you want work, I will say, please do integral P into change in the volume, P dV you do from V1 to V2, because that is where from V1 to V2 you are going. So if I put those values, I will get what is the work that is being done. Okay, and here if P is going to be constant, P is not going to change, I might as well take the P outside. I will say, hey, what is the value of P? Correctly tell me. Was the value of P is P external. Okay, it is constant P external into integral of dV from the limits V1 from the boundaries V1 to V2. That means it went from V1, it went to V2. What is this going to give me? Was P into V is work. So this is going to give you the work done by the system when it is expanding under constant pressure from a volume V1 to a volume V2. Are you able to follow, guys?
Yes, sir.
Okay, just make a small note of this because I will be erasing it. What will you do if my graph is not a goodbye graph, straight line, but this graph is something like this? What will you do now? This is also PV graph.
So we'll have to take the curve as a mathematical function of V, and then we have to integrate it.
Very good. That means here the definition of work is going to be same. Here also you will say W is equal to integral of P into dV. No difference. But then this pressure is there, na? This pressure is not constant. It is having P1 value here. Okay, when the volume is V1. It is having at volume V2, pressure is going to something. It is going to become more or less, whatever. Pressure is changing. Oh, that means if pressure is going to depend on volume, okay, that means you need an expression where P is expressed as a function of volume, correct? No? Just like y is equal to mx plus c, y is equal to f of x means I need an expression for y as a function of x. V is equal to u plus at means I need an expression for v as a function of t. Okay, so if it is not constant, I cannot take the p out as I did in the previous case. That means this p, please give me an expression. You have to give me an equation. How is this graph obtained? Is this PV is equal to K? Is it PV is equal to nRT? Is it PV to the power of gamma is equal to constant? Because I don't know what this graph is. Okay, you have to give me an equation for that. Once you give me an equation for that, that equation I will be using here in order to do my integration. But if you tell me, boss, this is not a pressure which is going to vary, it is a constant one, I am very happy, then I will say, just give me that constant value of pressure, 1 atmosphere, 2 atmosphere, whatever it is you give me, I'll take it outside, I will do the integration for volume. Are you able to understand this, guys?
Yes,
So perhaps they will say this is going to be P is equal to 4 into V to the power of 3 by 2 plus 10. Some fancy equation I'm giving. Okay, then what you will do, oh, thank you. You have given me P as a function of V. Then I will say this is going to be equal to integral of P. I will put here 4 into V to the power of 3 by 2 plus 10. This is the expression for P dV. This is what I will do. And I'll say this is W. Are you able to follow?
yes,
Okay. So the procedure is the same, but the way we will take it forward will change from case to case. That's what I wanted to say. All right. So we are taking this easy case, constant pressure case. Okay. Now, what is the definition of W? We said W is nothing but pressure into volume, change in volume. Okay. Now you will ask, boss, why are you putting minus P here? You only said no, P, work is equal to pressure into change in volume. What is this minus P here? Who can answer that question?
So because work done is negative, when pressure is taken to be negative.
Means why is P taken as negative?
So because the system is exerting a pressure on the environment, on the surroundings.
Yes. See, I have told P external means he's telling, yeah, you have taken some reaction, da. You have taken some, you have taken an acid, and inside this acid HCl, H2SO4, you are adding some zinc pieces. Okay. So what is going to happen? Hydrogen gas is going to come out. What will happen? That hydrogen gas is going to escape into the atmosphere. This is the typical thing which we are going to do in chemistry, right? Then we are going to say HCl plus Zn is equal to ZnCl plus H2. You will balance it and all that stuff, isn't it? 2 ZnCl, correct now? ZnCl2 plus H2. So for this reaction, I will say I want to do something. I want to say heat released. Wow, what is the internal energy change? What is the enthalpy change? So that is what we are driving at. Okay, now this H2 is getting released into the atmosphere, right? So most of the cases which we are dealing is like that. It's as if you have a piston, imaginary piston, and atmospheric pressure is being applied here. So this hydrogen gas which is escaping, it is actually escaping into atmosphere. It is not escaping into vacuum. It is escaping into atmosphere. Okay, that means where is this hydrogen gas applying the force? Hydrogen gas is applying the force this way. Where is the atmosphere applying the force? Atmosphere is applying the force this way. What is the force applied by the atmosphere on a given area? That we are telling is P. We are telling it is P external. Therefore, what is the force exerted by the gas on the piston? It will be equal and opposite to the atmospheric pressure. Hence, you are going to take it as minus P. Are you able to understand?
So,
Because see, you are pushing it, that means you are using the force in this side. If you tell me P internal, then I will take plus and I will take this is the direction of the force being applied by the gas. Where is the displacement? Displacement is going to happen this way. Why? Piston is going to move in this direction. Oh, okay, fine. Force is in this direction, displacement is in this direction. What is work? Work is equal to F dot S and cos theta is 0. So I can say F into S. Okay, but here we are taking this force now, we are taking the atmospheric pressure as the reference. P external, we are taking P external as reference. Therefore, when the gas is applying the force, it is opposite to the force exerted by the atmosphere. So this we are telling is F external. Therefore, the force the gas is applying is equal and opposite to that. That is why it is going to be minus F external. Therefore, this divided by area is going to be minus P external. Are you following, guys?
Yes, sir.
Okay.
yes, sir.
So this is to tell you gas is doing the work. Atmosphere is not doing. Gas is doing the work. Okay. All right. That part is covered. Go ahead.
Yes, it'll be area under the constant pressure line. W is equal to minus P external into V final minus V initial, which is equal to minus P external delta V. Here, negative sign needed for addressing the convention for work.
But another good way I have taught you now is this is the force applied by the gas. Okay, this is going to be equal and opposite to the atmospheric pressure. That is why we are going to consider, if you want to consider this, but you want to use the language of Px external, you will say this guy is minus P external. That's all. Okay, go ahead.
If the pressure is not constant at every stage of compression, but changes in number of finite steps, work done on the gas will be summed over all the steps and will be equal to minus sigma P into delta V.
This is what I was discussing, right? That if it is not a constant, then you have to tell me what is P. That is the second case we are discussing, which is like this, right? So I don't know what P is, then you'll have to tell me because you have to give me an expression for P. Otherwise, I cannot do it. Okay. And how I'm going to do it? I'm going to break up, if supposing this is your graph. Okay. I'm break it up into small areas. This is what is called the process of integration, right? This is what is called it going dV at a time. Take a small area so that you get a rectangle, break up the entire areas into infinitesimal small pieces, and then find the work or the area under the curve for each such small strip and then add it up. This plus this plus this plus this. Basically, that is nothing but this one because W1 is equal to P delta V, right? Minus P delta V. So W1 plus W2 plus W3 will be P1 into delta V, P2 into delta V, P3 into delta V. Summation of all that is nothing but the integral. Okay, and here the graph indicates that P is not constant like this, Baba. P is now changing. Some way it is changing. I don't know. You have to tell me. Okay, but however may be the variation of P. Okay, the process used to calculate work will be the same thing. This one. Okay, which is nothing but this one, integral dV. When you say summation sigma P into dV, it is nothing but integral of P into dV from an initial volume to final volume. Okay, adding all these things together, that is what is nothing but integration, which we have anyway covered in the previous explanation. Right, guys? Do you follow?
Yes,
Yes,
sir.
sir.
Okay, can you please complete this one, Adit?
PV plot when pressure is not constant and changes in finite steps during compression from initial volume V initial to final volume V final. Work done on the gas is represented by the shaded area.
Yeah. So when you take the curve like this, you have high pressure when the gas is, you have certain pressure. You will start from here. When the volume is high, pressure is low. As the compression is happening, volume becomes less and the pressure becomes high. This is how the P is going to vary. Okay, and how will you represent it? You will represent it in this way. Integral of P external dV minus, of course, is there. Vi to Vf is W. All right, guys. Now take a few minutes and make a note of this. Okay. And as you are making note, if you are having any questions, do ask me.
Yes,
Answer.
Please keep responding to me. Don't say silent. All right. Okay. So now we have to discuss certain processes. Okay. See, this is very important in thermodynamics, right? What we are saying is, yeah, you are always changing the system from some initial state to some final state. Okay. And you are interested in calculating certain energy transactions during this state change. Okay. How the system went from one state to another is very important. Okay. So, did it go from here to here in this way? Did it go from here to here in this way? Or did it go in this way? This is one aspect. Okay. The second aspect is, yeah, it doesn't matter how it went from one place to the other place. Okay. If I want to get it back from 2 back to 1, okay, will the curve follow the same graph? Is it possible that whatever I did in order to get it from 1 to 2, please pay attention. Huh? If you don't understand this, you're going to keep crying. Okay, please hold on a minute. Right. I was saying that from here to here it went. Is it possible that I reverse it? Okay, and I will retrace the curve back. Okay, if I am able to do that, then this process is called a reversible process. Okay, that means I can go from 1 to 2 and I can come from 2 to 1. The graph is going to be the same line. If this does not happen, if I am going to A to B this way, but when I have to get it back, I cannot get it back how much ever I try in this way. And I can only get it back in this way or I can get it in this way. This process is called a irreversible process. Are you able to follow this, guys?
yes,
Okay, how am I taking my system from one state to the other? Okay, it can be done in two ways. It can be done in a way such that I can exactly retrace my path and I come back to state one. Okay, if such a ideal process exists, that process is called a reversible process. You will only have one line here, going forward, coming back. Whereas if this is not possible, I went from here to here through this route. I will call this route number 1. And whatever I may try, I can never retrace this route back. I can only come back in route number 2 or come back route number 3. Route number 1, reverse not possible. That process is called a irreversible process. Did you guys follow this?
yes, sir.
All right. So let's discuss about this. Go ahead. Hannah, can you please read ma?
Reversible process work a special case. So what is a reversible process? A process or change is said to be reversible if a change is brought out in such a way that the process could at any moment be reversed by an infinitesimal change.
Infinitesimal change. Okay. Here, one of the cases where they are describing it, now it's like this. You imagine, supposing I have gas, it is getting compressed. What are you doing to compress it? Add grains of sand. You add one small grain of sand, let the piston, come little down, let it come to an equilibrium, add the second grain of sand. Again, let the piston, because now you are putting more this thing weight. So the piston is, the pressure is going to increase infinitesimally. One grain of sand, what can happen, right? Like that, you keep on adding different grains of sand, and after each addition of the grain of sand, wait, such that the process is in equilibrium, right? And then you achieve the overall compression by doing that. And what you will do, you would have gone from one state to this state. This is the compression cycle. Are you able to follow what I'm saying? Initially, it had large volume. By the time you add all the grains of sand, it would have come to this. This is the initial volume. It would have come to this final volume. Okay, now what will you do for the expansion process? Now do the ulta. Take this grain of sand, remove it off. So from here, you are coming to an infinitesimal state here. Allow it to settle to equilibrium. Then remove one more grain of sand. Then remove one more grain of sand. And you do the process very slowly such that you accomplish the expansion stroke. Okay, that means you came from here to here through the process of addition. Then through the process of removing the grains of sand, you are able to retrace the step back. Okay, such a theoretical process is called a reversible process. Are you able to understand?
Yes, sir.
Yes, sir.
Okay, and see, normally this is not going to happen. This is a theoretical stuff in ideal conditions, right? For example, you may say, boss, I have an IC engine inside my bike. Do you think IC engine is doing this compression stroke, expansion stroke in this kind of process? The answer is no. Hey, when you have the piston and, supposing the piston is somewhere here, this is called when the fuel is taken with the air, and the piston highly compresses it, and at this moment there will be some spark plug out here. The spark will come, so you have compressed gas inside through the previous stroke. Now you are going to ignite it. Boom, one explosion will happen. That explosion will create high pressure gas, and it will push the piston from here to here. That is called the expansion stroke or the power stroke. So do you think that kind of an explosive change in the volume can be considered as a reversible process? The answer is no, it cannot be. But in thermodynamics, we visualize, hey, is there such a process which can happen theoretically, where if I take it incredibly slowly, infinitesimally slowly, and I allow the equilibrium to be established at every case, okay, such a process possible? We say, yeah, theoretically it is possible. That such a theoretical process is called a reversible process. All right, go ahead.
A reversible process proceeds infinitely slowly by a series of equilibrium states such that system and the surroundings are always in near equilibrium with each other.
As is the case of addition of a grain or sand or removal of a grain or sand.
Processes other than reversible processes are known as irreversible processes. In chemistry, we face problems that can be solved if we relate the work term to the internal pressure of the system.
Sorry, please read it again.
In chemistry, we face problems that can be solved if we relate the work term to the internal pressure of the system.
So why we are saying this is, yeah, all the time when you say W, you say W is equal to minus P external into delta V. Okay, see, I don't want to talk about P external. Yeah, can you tell me how I can convert this P external into the pressure of the gas. I know this guy. Okay, I know this is a gas, this is expanding. I want to write P external in terms of P internal. Are you able to understand? Changing the subject of the equation. P external के बारे में बात मत करो. Can you express it in terms of P internal? Then what we say, okay, I am going to call this as a reversible process, this particular case. The definition is the same, minus Vi to Vf, P external dV, okay. Then I am telling this P external, no, you say it is P internal plus or minus dP. dP means very small change, equal to the addition of a grain of sand. Are you able to follow what I am saying?
Yes, sir.
Okay, for example, if I want to do compression, boss, this is my initial pressure. How much da? Something 1.0 atmosphere. Okay, now add a grain of sand. Okay, I will say now it is in equilibrium, right? So I will take this is P external. It reached equilibrium. Okay, what is P internal? P internal is equal to P external during equilibrium condition. Okay. Now add one more grain of sand. That means P external has now increased, isn't it? Hello.
Yes, sir.
Okay. Because P external has increased, what will happen? P internal now is less. Okay. That means now the P external has become P internal minus dP or P internal, P internal plus dP. Why? Because you added a grain of sand. Yes or no? Okay.
Yes, sir.
Then the system compresses. Now P internal also will increase. It has come to a state of equilibrium. At the state of equilibrium, now P internal again become equal to P external. Equilibrium reached. The new equilibrium. Add one more grain of sand. Oh, once again, P external has become more than P internal. So P internal minus dP has now become P external. Okay, once more the piston is going to come down because of this. And internal pressure is once again going to increase. And at the end of the equilibrium process, P internal will once again be equal to P external. Are you following? That means every time there is going to be a plus or minus dP. This is minus dP. If I am removing the grain of sand, what will happen? P internal will vary from the P external by plus dP, the ulta of that. That is why we say plus or minus. We can always express in a reversible process P external as P external can be written as P internal plus or minus a small change in pressure, okay, which can be visualized as if a grain of sand has been added or removed. The pressure equivalent to that is the delta P, okay, and then we say into dV. And therefore, we write this W reversible as P external replaced by P internal plus or minus dP into dV. Please go through this and let me know if you're having any concerns. So we are here. Go ahead.
As this is a slow process, dP can be thought of as an oh my god,
Infinitesimal.
oh,
Infinitesimal.
infinitesimal pressure difference with a plus or minus sign that can be used both for compression, P internal minus dP, or expansion, P internal plus dP.
Whatever we discussed, right? Instead of external, let's talk about from internal. See, I'll tell you the context here. Okay, supposing you say, yeah, I'm having a gas and the gas is expanding. Then I'll say, oh, do you know the volume of the gas? Oh yeah, I know the volume of the gas. Okay, do you know the number of moles of the gas? Yeah, I know the number of moles of the gas, right? Then if it is an ideal gas, maybe that particular pressure, that temperature for that, it is behaving as an ideal gas, then I can use PV is equal to nRT. That means I can use the ideal gas equation and I can get the internal pressure of the gas in terms of certain constants here. Number of moles constant, gas constant, universal gas constant. Hey, I am doing the entire experiment at room temperature, and this is the volume of the gas. So if these parameters are known, I am not going to be dependent on where are you doing this, which location, what is your external pressure. I don't want. Is it a humid day? What is your altitude? Read from the barometer. Nothing. I have everything which I have is in my control. That is what I want to achieve. Okay, so because I am a chemistry pundit, I know PV is equal to nRT, ideal gas equation. No longer I am going to depend on external pressure. I can express this in terms of internal. This dP, mathematically I'll ignore because anyway it is a very small thing. I ignore and I get the internal pressure of the gas in terms of this ideal gas equation, and completely I can reduce my dependency, remove my dependency from P external. Are you able to follow this, guys? That is the whole point why I want to express P external as P internal plus or minus dP. Did you guys understand this?
Yes, sir.
Sir,
Wait,
if
tell me.
dP is an infinitesimal change, can we take P internal is equal to P external?
Yes, you can.
Okay, sir.
That is what we are telling. Since dP is very small, so here we are doing P internal plus what do you call dP into dV. That means this is going to be P internal into dV plus dP into dV. Then we say, hey, first of all, this volumetric change that is happening because you are adding 1 grain of sand, that itself is small, and the pressure change that is happening also is small. This small quantity into this small quantity is going to be near zero. So I will ignore it. Once you ignore it, then this is what is going to remain. This one I will integrate. Are you able to follow?
Yes, sir.
Yes, sir.
Okay, so P internal into dV plus dP into dV, and the second term is tending towards zero, you will ignore it. So as you just now said, that dP also is removed from the picture. We say W reversible is equal to VI to VF, P internal into dV. That means P external has vanished. And this how to calculate, I always told you, if it is going to be a pressure and that is going to change, you have to tell me what is the expression for it. Otherwise, I cannot. Either you give me some fancy expression which is custom made, or you tell me it is an ideal gas. If you tell me it is an ideal gas, I will use these expressions which are well known to me. These guys, if you don't tell me it's an ideal gas and you tell me the pressure is changing with respect to volume, time, whatever, then please provide me with the necessary equation. Then only I can, what do you call, achieve this integration. Otherwise, I can't. Is it okay?
Yes, sir.
And that is what has been detailed here. Go ahead.
We know that for an ideal gas, PV is equal to nRT or P is equal to nRT by V. Work reversible is equal to the negative integral of
This
nRT.
no, this P I am now, this is P means P internal. This guy. This is the gas out here. And this gas is following the ideal gas equation. Okay, so now I will say this P is now become P internal is going to be equal to nRT divided by V. That I am substituting here. nRT divided by V, but V is going to change. Number of moles is not changing because the mass of the gas is the same. Universal gas is now constant is not changing. Temperature is not changing. Okay, that means I will only be left with dV by V. That means all this constant comes out. That means it is nRT into integral of dV by V. Okay, and just now we saw for integral 1 by x is nothing but log x. ln means natural logarithm. So this becomes minus nRT natural logarithm of v. Okay, when you apply this, when you are applying this integral, that is one thing which I missed telling you. I will tell you. Hold on a minute. Okay, so if supposing you say integral of sine x from 0 to pi by 2. Okay, that means I am telling my curve is there. My curve is the sine x curve. The sine x curve is going to be something like this. Okay, but I want to find the area under the sine x curve only from 0 to pi by 2. Oh, this is going to be 0 to sine pi by 2 means it is at the peak. That means this point. Okay, oh, what is the function the sine x? I drew the sine x curve. From where to where you want to find the area? Only from 0 to pi by 2. That means you want only this area. That is what these limits mean. Instead of 0 to pi by 2, supposing you say 0 to pi. That means you will calculate, okay, the new area which you are interested in will be this guy from here to here. If you say from 0 to 2 pi, that means you are interested in this entire area from here till here. Okay, the shape of the curve is the same. That is governed by this function. Area under the curve is defined by from where to where you want to take the area. Are you following this, guys?
Yes, sir.
Yes.
Okay, for example, familiar example, v as a function of t. Okay, velocity is there, time is there. Assume this is the vt graph. Okay, you say, boss, I want the distance traveled from t is equal to 5 seconds to t is equal to 7 seconds. Only in these 2 seconds, tell me the distance traveled. Then what will you do? Hold on, da. You want to find distance. Distance means integral vt. Integral v dt will be my distance or displacement. Okay. I use both of these interchangeably, but you know what I mean. Then from where to where you want, from t is equal to 5 to t is equal to 7. Okay. A complete area under this is here. This is called indefinite integral. When you are going to apply the boundaries for it, t is equal to 5 till t is equal to 7. Okay. I want the area under this. Okay, area under this is distance. Area under this specific area will be the distance traveled from 5 to second. Okay, so here I will say do the integral of this, but take the boundary from 5 to second 7. Are you able to follow this, guys?
Yes, sir.
Okay, so integral v supposing I say is our good old v is equal to u plus at. Okay, then I will say, hey, this v ke badle mein you substitute this u plus at dt. This is integral I want to do from 5 to 7. This is going to be the distance traveled from 5 to 7. Okay, what is integral of u dt? U is a constant, bro. It is the initial velocity before all the things started. Okay, u is constant, or you can split this just like derivatives. Na? You will say this is u dt plus integral at dt. You're doing this, then you're doing this. Are you following me so far, guys?
Yes.
Then what you do, hey, this u is constant. This u is not changing with respect to time. Velocity is changing. The body was having some initial velocity u, after which the accelerator pedal was, accelerator pedal was pressed. Acceleration is happening after this point. Oh, then we will say we will take u as constant, right? So therefore, this will become 5 to 7 u into integral of dt. Then here acceleration also is constant. Acceleration is not changing. plus a into integral of t dt, both of them from 5 to 7. Then you will use integral of dt is nothing but t. You will say u into t plus a into integral of t to the power of 1. Whatever I told you, t to the power of 1 plus 1 divided by 1 plus 1. That means this s has now become ut plus half at square, which is a well-known formula for displacement. But we have to apply this from 5 to 7. Okay, because this is like indefinite, this is definite, from which to which. Then what you will do here, this whatever is the variable here t, first you will put upper limit. So you will say u into 7 plus a into 7 square divided by 2. So in the entire expression you have put upper limit minus, open the bracket, u into 5 minus plus a into 5 square by 2. Close the bracket. Okay, this is the definition of applying the boundaries. Okay, you will find the value with substitute the top boundary first, then you do minus and then do the bottom boundary. Okay, did you understand this?
Yes, sir.
Yes, sir.
Okay, so I can give you a simpler example. Okay, I will tell you simple. Supposing it is integral of x. Okay, or let us say integral of dx. Integral of dx from 1 to 2. Integral of dx is nothing but x. X between the limits 1 to 2. What will that be? Tell me, Adit.
So it'll be
That is why I gave this example. Keshav, tell me what will this be?
So integral of x is x square by 2.
Hey, integral of dx da.
Oh, okay, sir. So for x, you have to do 2 minus 1.
2 minus 1. Put x as the top one, 2 minus lower limit, x as 1. Okay, let's do one more simple thing. Integral of x dx from 2 to 3. Tell me, Adit, now. Integral of x is how much?
3 minus 2.
Integral of x dx is how much?
So integral of x dx. So will be 3 minus 2 only, right?
Integral of x. See, here it is integral of dx. Integral of dx is x. First, you have to do the integration.
Yes, sir.
So here it is integral of x, x to the power of 1 basically. So what will be the integral of x power of 1?
Oh, so that'll be x to the power n plus 1 by n plus 1.
X square by 2 basically. Okay.
Yes, sir.
Once you finish the integral, now you have to apply 2 to 3. And first you have to do upper boundary minus lower boundary. Go ahead and tell me.
So it'll be 3 square by 2
9 by 2
and 2 square by 2, 4 by 2.
and minus
Minus 4 by 2.
minus 4 by 2. You substitute whatever you get in the answer. This is integration over. Once integration is over, first you put upper one in the variable minus lower one in the variable. You have to fully finish. Here you had this integration was the answer. This is the answer you got, no, x square by 2. Here after doing the integration process, the answer I got, the integral is ut plus half at square. You understood?
Yes, sir.
So when you're doing this, the whole thing you have to put 7 first. U into 7 plus a into 7 square by 2. Upper boundary put minus u into 5 plus a into 5 square by 2. Did you understand?
Yes, sir.
Okay. The reason for this is, look, if I say find the area, I will take simple example, okay? Supposing constant velocity is there, okay? And this is time. And I will say, boss, find me the area, find me the distance from between 3 to 5, okay? Then you, how will you find it? Okay, you will say, boss, first let me find total distance traveled till 7 seconds. Up till 7 seconds, how much distance was traveled? Basically, you will do S7. Okay, that means when you do the area under the curve, sorry, not this thing till 5 seconds. Okay, that means, do you think this, when you compute this area, this is from 0 until 5, you will get the distance traveled up till 5 seconds? No answer. My God, you guys are wonderful, yeah. Someone say something, no?
Distance covered till 5 seconds.
5 seconds, right?
Yes,
Oh,
sir.
very good. Next, what I will do, boss, but I want only from 3 to 5, means I want only this area. I want only this area. How to do it? Can you tell me how to do it? This is the area that I want, but what I got is from here to here I got. Let's say this is like 16 meters, but this guy is only 30 meters, or let's say 40 meters. From here to here, when I calculated, I got 60 meters.
So we'll have to subtract the initial area.
Correct. Then you will say, boss, you took, you wanted distance traveled from 3 to 5, but you have taken total distance traveled till 5 seconds. From this, you find out what is the total distance traveled till 3 seconds. Means you calculate this area, 0 to 3. Then subtract, supposing you get this as 20 meters. Then the required area distance traveled from 3 to 5 will be S5 minus S3, isn't it? Yes or no? Which will be 60 minus 20, the necessary area 40 meters. Correct, no?
Yes, sir.
So
Yes, sir.
this is what we are doing here. This is S5 means we are putting upper boundary. From here to here, I am calculating total area under the curve till the upper boundary, and I want it from V initial to V final. Okay, some volume, something to something. So this is the change in volume I want. So I will find the total till V. You understood what I'm saying, right? So you do that, you subtract it, then you will get the actual work done, actual distance traveled from one particular point to other particular point. Okay, so this is going to represent the upper boundary. This is going to represent the entire work done till that. This is going to represent the lower boundary. This area is going to represent the entire work, distance, whatever. And this minus this will be the desired area that you want. And that is what we are accomplishing when you do this. So you have to put V final in whatever the answer you get minus V initial. That is how we will take the definite integral. Is it all right, guys?
Yes, sir.
Yes, sir.
Okay, just take a minute and put this example with you. Okay, you do simple integral x dx करके डालो, and you say you're doing it from 2 to 4 or whatever, and say this is x square by 2. Then put this boundaries here. Put this diagram also here so that you understand what you did. So you will see 4 square by 2 minus 2 square by 2. Shade the areas, and so because you'll forget it. And once you're done, let me know. I will continue. Look at this. I am saying find me the integral of nRT dV by V from V initial to V final. Okay. Nihar, can you take me through how you will do this, Bobby? First, when I ask question, no, say, sir, I acknowledge,
Sir,
I've heard you. I am thinking. Some communication.
sir, 1 second, I'm thinking.
Thank you, Ma. Nihar, I'll help you out. N, R, T are the constant.
Yes, sir.
N is number of moles.
R is constant.
T is also constant. Integral of Vi to Vf dV by V.
Yes, sir.
Just like integral of x dx is equal to x square by 2. This is like sin x is equal to cos x derivative. Integral of x is equal to x square by 2. Till here you understood, right?
Yeah, yes, sir.
Like that, I also told you integral 1 by x dx. How much was that?
I'm not sure, sir.
You are not sure, you didn't make a note. Doesn't matter. It is log x. Because I told you d by dx of log x is equal to 1 by x. Therefore, integral of 1 by x is equal to log x करके बोला था. Okay?
Okay, yes,
And
sir.
I asked you to make a note also. Okay? Doesn't matter. So this is dx by x, this is dv by v. If this is log x, ln means natural logarithm. What will this be?
Log V.
Okay. Minus nRT. Okay. I have taken the integral natural logarithm of v and vi to vf. Are you taking notes, guys, when I'm telling?
Yes, sir. I
Yes, sir.
didn't note down the last formula. That's it.
Last form, okay, no problem, excused, okay? Okay, now that you know dv by v is log v or log to the base ev, apply the limits and tell me here what you will get.
Minus nRT log VF minus VI.
Very good. Minus nRT, okay, natural logarithm of v final, okay, minus nRT is common, natural logarithm of v initial. Is it okay?
Yes, sir.
Now, this is log A minus log B. What will you say for that?
Log A by B.
Very good. Minus nRT logarithm of A by B. That is what is written here. You understood?
Yes, sir.
Okay, so for this we have done the integration and we have got this. Then we have applied the limits, upper limit minus lower limit. You got this in between. Then you recognize this is log A minus log B and you know it is log of A by B. You have put it. That is the expression provided. It is a reversible process and it is an ideal gas. That's why we say WREF. This is applicable for reversible process. For, sorry about that, and for ideal gas. And this is a very important piece of formula. This formula is very important. It is going to be used for thermodynamics in physics as well as thermodynamics in chemistry. Okay, so please make a note of it as a derivation and learn it now itself. Okay, ask me questions.
So it's 2.303.
Log e to the base 10, my dear.
Oh, okay, sir.
What is log e? Log, if you put in calculator and you put e, you will get something. What is that? Guys, none of you are doing it, huh?
Doing so.
Oh my God, yeah, you guys. I am going on telling you stuff. You're not even interested here. You want to just mug it and go ahead, huh?
So log E is 0.434.
0.43429. Okay. Now you
Yes.
tell me, supposing you have natural logarithm of x. Okay, something. And you're telling this means it is log to the base e. Okay, how can you convert this into log to the base 10? That's what we are doing now. Here we had NRT, natural logarithm of some number. We are having natural logarithm of some number. Now I am saying it is become logarithm, log to the base 10. Okay, how this process can be achieved?
So by dividing log to the base 10 by log to the base 10 to e.
See, here you do. This one can be written as log x to the base 10 divided by log e to the base 10. This is log x to the base, log x by log e, basically, this one. That base can be anything. It can be log 10, it can be log a, it can be log 1.3456, any number. Okay, but because you want to the base 10, log x to the base 10 by log e to the base 10. Okay, this is what you want. Okay, that means you have to what do you call, divide this, whatever you have, with this number, right? So you 1 by x you do 1 by 0.43429. How much are you getting? 1 by
2.3037.
2.303, right? That means 1 by log e to the base 10 is nothing but 2.303. So you're using these definitions. Okay, you're finding, this is the value of log e. 1 by log e is this much. Based on this conversion, you're able to say this is minus is already there, 2.303 NRT log this to this. Is it okay?
Yes, sir.
Yes, sir.
Alrighty. So that's one list. Because you cannot have anything mysterious here. Everything is simple math and what do you call, concepts. That's all. All right, let's move ahead. Okay. So far we have been telling a reversible process, very special process, blah, blah, blah. Then our question is, hey, what do you mean by irreversible process, then, right? So, Keshav, can you help me continue this?
Yes, sir. These are not so what is an irreversible process then? These are not slow processes where equilibrium is established in each step. This means that the path of the curve cannot be retraced back if we toggle between states. Heat is permanently lost to the surroundings.
Okay, so this process which is there, where you are going in one way and coming back in another way, what will you want to call this as? Reversible or irreversible?
Irreversible, sir.
Okay, whereas what will you call this as?
Reversible.
Okay, so the fact that the states are not on the same line. Okay, there is an area between these two paths. Okay, this area is nothing but work done, which is lost. Okay, here if you see, there is zero area. There is no area between the two paths. So this is a reversible process, whereas this is a irreversible process. Okay, please continue, then you make a note.
Here, pressure internal cannot be used for computing work done, and we have to use pressure external alone.
Okay, so what you are telling is, hey, this grain of sand principle will not work here because the process is not proceeding incredibly slowly as it did in the previous case. So that kind of adding grains of sand, blah, 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 that will not work here. Okay, then how will you find the work? You can't relate P internal to P external because like a big bang, it is expanding. Then, boss, you have to tell me what the external pressure is. You tell me the external pressure, only then I can do the I can use the work done. You're able to follow, right? I cannot in this case write this as P internal plus or minus dP into dV. Not possible, sorry. Okay, because this concept of dP is not there, because you are not doing it infinitesimally slowly. You are not waiting for equilibrium states to get established. You are doing it much rapidly. Okay, so sorry, boss. My attempt to express P external as something with respect to P internal, I cannot do that, boss. Okay, then use P external itself. Is it okay, guys?
Yes, sir.
Yes, sir.
Okay, that means the equation which I have to use in order to calculate the work done when it is something like this is this. The equation which I have to use in order to calculate something which follows this process, reversible process, is this. Okay, so here this will be W reversible, whereas this will be simply work done. We don't use that suffix REV out here. Is it okay, guys?
Yes, sir.
For whom your teacher is teaching physics and now you're learning chemistry, right? The equation, first law of thermodynamics, may seem little different. Okay, for example, in chemistry now we will say I want to talk about the first law of thermodynamics in this way: delta U is equal to Q plus W. Okay, whereas in physics, you will say, no, delta is equal to Q minus W. Okay, so what is this difference? It is just the way in which physics and chemistry perceives the system and the way the system is doing the work. Okay, for example, chemistry, no, it says, boss, if the system is doing work, external work, then the system is losing energy. Yes or no?
Yes, sir.
Okay, I would like to take this work as minus W. Okay, in physics, what you will say, yeah, if a system is doing work like an IC engine is expanding and it is actually doing the work, I would like to take it as positive work. Okay, so they will say this is the system is doing the work, it is plus W. Okay, it is this aspect of how we see the system. Okay, both the cases it is the same thing. Here a gas is expanding and doing work. Here also the burnt fuel is expanding and doing the work. The work is the same scenario is there. But as far as chemistry is concerned, we treat the work differently. As far as physics is concerned, we treat the work differently. Are you able to follow this, guys?
Yes, sir.
Yes, sir.
And for that reason, you also must be well aware of this. Previously, when I used to teach, people will get confused. Why is it you say it is a law, but you are using different equations for this one? Okay, that is why I have put this specific slide. I want you also to make a note of it. And I have compared when exactly the same thing happens in both the cases. Okay, for example, system is under expansion. Here also system is under expansion. System is doing work. Here also system is doing work. In chemistry, sign convention work is negative. Here sign convention work is positive. If you plonk that sign convention, what is the formula for W? We say minus P external into Vf minus Vi. Do you guys agree to this?
Yes, sir.
Okay, therefore, if you look at Vf minus Vi, you are expanding the, what will Vf minus Vi be? Positive or negative or?
So it'll be positive.
The positive.
It is written, isn't it? Vf minus Vi, when you are expanding, initially your volume is less, you are expanding, final volume is more, final volume minus initial volume will always be positive. So this entity is positive, okay? Minus P external into positive will be negative, Okay, then you are putting this minus sign here, that makes it positive. Okay, therefore you have one more minus in front of it because work is minus, right? Therefore everything put together, work, you will be getting it as negative. Okay, because this is W. If you want to do minus of W, it will be minus of minus P external into delta V. Isn't it? This minus I have put here. Just W is inside wala. Okay, and then this delta V I am analyzing now is positive. Minus into plus, this entire thing is negative. This negative into negative is, sorry, somewhere I flopped. Huh. So don't go for this guy. This don't go for this, guys. Just say W in terms of 1 minute. Just give me 1 minute, please. Guys, one small clarification is there is no minus W in front of it. You should just take W. Okay. W in chemistry is defined as minus P external into change in volume delta V. Okay. And this change in volume is positive. Therefore, minus P external into minus into positive is going to be negative. Okay. So therefore, W will be negative here. What about the case of, okay, hold on. So if you plonk it now, what will you get? Delta delta U is equal to Q. In this specific case, W is becoming minus W. So we say Q minus W, or Q we will say is delta U plus W. In fact, if you see this, this is what we have seen yesterday. Isn't it? This is the case where we are getting Q is equal to delta U plus W when we discussed first law of thermodynamics. Okay, here again. Okay, this is a specific case where we are dealing with expansion work. Q is equal to delta U plus W. Now let's look at what is it for physics. Here, sign convention means system is going to do work, so it is going to be taken as positive. That means for the same case, delta U is going to be Q. So here you will get delta U is going to be Q minus, something is going off here, I'm not getting it. So this is the base expression for physics, delta U is equal to Q minus W. For expansion, W is going to be positive. So we will put that W as positive here. That means the final expression will be delta U is equal to Q minus W itself. There is no change. Okay. Whereas if you take the case for compression, compression here we have to take positive sign. Whereas in this case, compression we have to take negative sign. So here you will get minus of minus W. Why? Because this entity here, delta V will be negative. Then outside you have minus. So this into this, we will get positive work here. Therefore, if you see, here we are going to get delta U is equal to Q plus W as it is. Or Q will be delta U minus W. Whereas in this case, you have taken this delta U is equal to Q minus W. Now we have to put W is equal to negative. Okay. Now if you put delta is W is equal to negative, you will get Q plus W. Delta is equal to Q plus W for physics. Okay. So take a minute and make a note of this particular difference between the two guys.